Today's video we are going to solve inequalities and then graph our solutions on a number line. The great news here is solving an inequality is the exact same process as solving an equation. Exactly what we reviewed in class the day before. So, number one, if this were an equal sign, I would add 6 to both sides, but it's not. It's a greater than sign. It doesn't change what I do. I still have two separate sides. I treat this like an equal sign. I add 6, I add 6. It leaves me with x on this side. Negative 4 plus 6 is 2 on this side. And I bring down my symbol. I don't change it. There's my solution. X is greater than 2. And I graph it on the number line, just like we did in the previous video. I need to have 0 on there. I need to have 2 on there. It's positive, so it'll go on the right. I'm going to graph this with an open circle because it's a greater than, not an or equal to. The variable's on the left, so I can graph to the direction of the arrow, which is pointing to the right. So it's combining our two concepts. Okay. Doing number 2 together. Okay. Here's my inequality symbol. I have 2 times x. I do the opposite. I divide both sides by 2. I get x on the left. I get negative 3 on the right. I bring my inequality symbol straight down. There's my solution. 0, negative 3. Negative is to the left of 0. Another open circle because it's not an or equal to. Variables on the left. I can graph in the direction of the arrow, which is pointing right. And there's my solution to number 2. For number 3, again, it's a one-step process here. X over 2 means it's a fraction, which means it's dividing. I multiply both sides by 2. Not 2 over x, just 2. I'd leave the x where it is. That cancels the 2's here. It leaves me with just x. 5 times 2 is 10. My symbol's greater than again, so x is greater than 10 means I need a 0. And I need a positive 10. Another open circle, and another shade to the right. Go ahead and press pause if you have questions or concerns. Make sure you write it on the right-hand side. Okay, so for number 4, it's the first one where we have two new things. One, it's a two-step equation, or inequality, and the second is it's no longer just a greater than symbol. My process here needs to be the same as solving an equation. I have two sides. X is on the left, I keep it there. Subtract 2, subtract 2. Add or subtract before I multiply or divide. The 2's go away. I have 4x, negative 22, minus 2. Don't be afraid to use your calculator if you need it. We get negative 24. My symbol comes straight down. I don't change it at all. Divide by 4, divide by 4. 4's go away. X, negative 24 divided by 4. Use your calculator if you need it. Negative 6. Symbol comes down. I don't change it at all. I have 0. I have negative 6. This time I do fill in my circle. It's a completely filled in circle because it's an or equal to. Variables on the left. Arrow points left. I shade left. And the last problem on this front page is variables on both sides. So here's my two sides. That's the wall that's divided up or set up by the inequality symbol. Now the variable's not x. Treat it the same, and we will graph it the same. We need to get that variable on the same side first. That needs to be our first step. So since we have a b term on the left and on the right, that negative is part of that b term. I'm going to move this term that way. If I have to hop over that fence, hop over that line, or that inequality, I have to use inverse operations. Add 2b here, add 2b here. 3b plus 2b is 5b. I bring down my plus 12, I bring down my symbol, I bring down my 27, and those cancel. Now b is by itself on the left, or the only b on the left at least. I have to do my two-step equation. I have plus 12 that I have to get rid of first by subtracting it from both sides. 5b is greater than 27 minus 12, which is 15. Now I can divide both sides by 5. b is greater than 3. There's my solution to my inequality. I have 0 and positive 3. This is another open circle and another shade to the right. This is a good time where if you have questions, go ahead and press pause. Try to write your questions down on the right-hand side so we can follow up in class. When you're ready, unpause. Okay, so I said the good news is this is exactly the same as solving an equation, and unfortunately that was a little bit, not of a lie, but of a little misconception here. There is one slight difference, and it's this major rule. The process we do is identical, so that wasn't a lie. Everything we do to solve my inequality is the same. The major rule is that when I multiply or divide, both sides, I'll specify that, by a negative number. I need to reverse the inequality sign. So let me kind of refresh your memory on things we did. Here in number 4, we divided both sides by 4, so it's negative divided by positive. We don't do anything different there because I divided by positive 4. If my denominator is negative, that's where I'm to make an adjustment. Example would be here in number 6. My inequality symbol is a greater than or equal to. I have to get rid of a negative 3. When I divide by negative 3, my denominator is negative here, and I'm doing this to both sides. It cancels this side, leaving me with my x. 12 divided by negative 3 is negative 4, so the process is identical. But because I divided by negative 3, a negative number, the symbol, which was pointing to the right with an arrow or with a line under it, now has to reverse and point to the left. In class, we will do an example and illustration as to why this happens. For now, I want us to understand that rule, because that changes the way my solution works. I still have to put 0 and negative 4. I still am going to have a closed circle, but instead of graphing to the right, which is what the original symbol would imply, I graph to the left, because my variable's on the left and the arrow points left. We can always go back and double check and just pick a number. Something to the left of negative 4 would be something like negative 5. If I plugged that in, do I get a solution? Negative 3 times negative 5 is positive 15. Is that greater than or equal to 12? It is, so I know I graphed in the right spot. And if I pick something to the right of my graph, say 0, negative 3 times 0 is 0. Is that greater than or equal to 12? No. So we know these are not solutions, and what we did graph was correct. Two other examples. One, if it starts as a fraction and it's negative. And we saw at the beginning of our notes, it could start as a fraction and be positive, nothing changes. But if it starts as a fraction and it's negative, now I am still multiplying both sides by 6, but because it's negative, I have to get rid of that. I'm going to multiply both sides by negative. Now I'm multiplying by a negative. My symbol, which was pointing left, needs to point right. Those negative 6's cancel here, leaving me x. Negative times negative is positive 12. I have 0 and 12 on my number line. Open circle, because there's no line under this. The variable's on the left, arrow points right, I graph right. The other chance that we see this is when we're actually solving more than one step as well. I don't do anything with this inequality symbol when I'm subtracting both sides. So in this last problem today, I have a positive 8. I have to subtract a positive 8. I do not reverse my symbol when I subtract. Only when I multiply or divide by a negative. But this does leave me, when that cancels, with a negative 2x on this side. Symbol stays the same. And I get negative 18 on the right side. Now, however, I'm dividing both sides by a negative. My denominator on both sides becomes a negative. That's when I do cancel this side, but switch my symbol. Negative divided by negative is positive. 18 divided by 2 is 9. There's my solution. 0 and 9 on my number line. Closed circle because it's in or equal to. Shade right because the variable's on the left and the arrow points right. That's it for tonight, folks. Make sure you get your questions written down on the side so we can address them in class. Have a wonderful evening.